It seems that around these chance coincidences, the local field potential has a stronger modulation. It seems. In the next panel, you see a comparison again of the spike-triggered average of the isolated spikes in gray and to the unitary event-triggered local field potential.
What you call the spike is the maximum amplitude of the whole spike?
The spike is reduced to a spike.
Is with the maximum amplitude of the spike? I mean the real spike? Used to see the...
It's a template match. The sorter is a template match which matches the whole spike shape, and I don't know where the representation of the spike time is. But first of all, just to remind you, this is why I mentioned this at the beginning, we don't use spikes recorded on the same electrode as LFP. Yeah? And second, the timing, the duration of a spike is typically 1 to 2 milliseconds, and we are talking here about 200 milliseconds. Yeah? So we do not expect to see the spike shape in these relationships because they are all from different electrodes. So, and also this is in the beta range. This is rather slow. Yeah. Still, what you see here is that it appears as if the LFP around a unitary event has a much larger amplitude modulation than isolated spikes. This band around the dark gray line is the standard deviation from random drawings as much as we had unitary events as triggers in order to be comparable. And here in this display we compare the chance coincident spike-triggered average and the local and the unitary event-triggered local field potential, and you see that even for the chance coincident, even for the unitary events, it's larger than for the chance coincidence. These increased spike-triggered averages, I mean the amplitude of the spike-triggered averages, here is some statistics on that. So what we find, this is very consistent for both monkeys we evaluated, and these are these two bars. And typically about 70% of the neurons show a larger spike-triggered average amplitude for the unitary events as compared to the isolated spikes. An interesting phenomenon here is that the more neurons simultaneously recorded, the larger is the spike-triggered average we find, which you can see here in this display. So for example, if we compare how many CC-triggered spike-triggered averages are larger for isolated, it's the more neurons we recorded simultaneously, which may hint to the fact that this effect of the enhanced of the synchronous activity is presumably even a higher order correlation, and not only a pairwise correlation based. So, or in other words, that if more neurons may be synchronized altogether, then also the local field potential may have a larger amplitude deviation. But this is what we are currently looking at. We didn't analyze this yet, but these are hints in this direction. In this display you see a correlation between, we looked at the firing rates of the neurons, how this is related to the local field potential amplitude, whether there is any kind of relation. But as you can see from all these dots, there isn't any. Yeah? Which is a little bit in contrast to what people recently showed in a number of publications. Now, the open questions are the increased spike-triggered average amplitudes due to larger LFP amplitudes, which I first thought, or is it due to a better locking of the spikes to the LFP phase? And this is what we will now separate in the next few slides. So our first hint is when we look at the oscillation-triggered spike histogram. Now instead aligning the histogram onto spike times, we now align onto the maximum amplitude of the local field potential and align on these, and then relative to this, create a histogram of the spikes. Yeah? Now again, separated for the isolated, for the chance, and for the unitary events. And I think what you can clearly see is that the modulation of this histogram from there to there to there is becoming more strong. And in addition, that there is an increase of spike probability at the decaying phase of the local field potential. So there seems to be an indication for phase preference of the spikes. So what we did next is for the local field potential, we extracted phase and amplitudes by using the Hilbert transform. So you see here an example of, this is an individual trial. Here you see the frequency component, the frequency contents as a function of time resolved. And as I said beforehand, we typically see a very strong signal component in the beta band, which then breaks down when the monkey starts to make his arm movement. Here you see 3 individual trials of the filtered local field potential. I don't know how wide the filter was, but it was around 17 Hertz. And here you see the filtered signal. Yeah? And in addition, you can also see the extracted envelope, the instantaneous envelope of the signal, and the instantaneous phase. So these little red lines are the phases. Now, since we have simultaneous also the spiking activity, which is these lines here, you can extract for each spike time it's the envelope of the local field potential and the instantaneous phase. Yeah? Now we can extract these two. Now we extract these two measures for our different spike types, and can look at the phase locking, for example. So here again you see separated for isolated chance and unitary events. Now a histogram of the spikes, however, and this histogram has the duration of 2 pi, so one oscillation period of the LFP oscillation, and you see the spikes entered at the corresponding phase they occurred at. And you see that for the isolated spikes this is nearly flat. However, for the chance coincidences there is a preference. Here is the maximum of the modulation, here is the minimum. So on the decaying phase there is a preference for spiking, and for unitary events this preference is even enhanced. Yeah? What you in addition can see in black is a predictor, because it's not totally flat for the isolated spikes, but it has some small preference. And if you would combine, so to say, for two spikes which have a small preference, if you would combine these, you would expect some increase in the locking. This is shown here as the predictor. So, in other words, the chance coincidences seem to have a locking preference which is comparable